In this section, we'll define what a proper subset is and use the definition to explain if one set is a proper subset of another. Proper subset is symbolized as a sideway U. Note that it has no equal sign underneath it. So if A is a proper subset of B, then A must be strictly contained in set B, with no chance of being equal to B. To prove that set A is a proper subset of set B, you need to check two conditions. The first condition is similar to subset, that is, every element in A is also an element of B. The second condition is to check that there is at least one extra element in B that is not in A. So B is a bigger set than A. Hence, B can never be equal to A. Symbolically, A is a proper subset of B means that for all element X, if X belongs to A, then X also belongs to B. And at the same time, set A is not equal to set B. To help reinforce what you have just learned, you can think of B as a set which contains all the elements of A plus some other extra elements. When that happens, A is definitely a smaller set than B, so they can't be equal sets. In this example, you're given sets A, B, and C as shown. In part A, you are asked if C is a proper subset of A. For proper subset, you need to check that two conditions are met. Let's start with condition 1. Elements 4, 1, and 3 in C can also be found in A. So every element in C is also an element in A. Hence, condition 1 is met. How about condition 2? Comparing sets A and C, we see that set A has two extra elements, namely 2 and 5, which are not in C. So condition 2 is also met. We can therefore conclude that yes, C is a proper subset of A. Let's move on to part B. Is B a proper subset of C? Again, this is about proper subset, so we need to check two conditions. Let's start with condition 1. Elements 4, 1, and 3 in B can also be found in C. So every element in B is also an element in C. Hence, condition 1 is met. How about condition 2? Well, B and C are actually equal sets. So C does not have any extra element that is not in B. So condition 2 has been violated. We therefore conclude that no, B is not a proper subset of C. In summary, to check if set A is a proper subset of set B, we do a check on two conditions. For condition 1, we need to check that each and every element in A is also an element in B. For condition 2, we need to check that there is at least one extra element in B which is not in A. Two things can happen from here. If both conditions are met, then we conclude that A is a proper subset of B. On the other hand, if condition 1 is not met, then give a counterexample by listing at least one element in A that is not in B. If condition 2 is not met, then give a counterexample by stating why condition 2 has been violated. Either way, we can then conclude that A is not a proper subset of B.